Hello, everyone, and welcome to OC Live, a weekly broadcast on blockchain technology and token economics, featuring some of the industry's leaders discussing the latest trends. And today we have Trent McConaghy from Ocean Protocol, and today we're going to be talking about AI on the blockchain. And we just announced yesterday our lineup of speakers for the rest of the month. So if you want to check out what's in store for October on OSC Live, be sure to check out our Medium post. This is our 25th episode. So very excited to have done this many episodes and keep this podcast going. Video quality should be improved now. I should no longer be overexposed as in some past videos, as I'm using a DSLR now. So let us know in the chat if everything looks stable as far as video and audio. Trent, welcome to OSC Live.
Hi, thanks for having me.
So you're very involved in AI, and Ocean Protocol is focused on providing data for the use of AI, and you've been involved since the early '90s, and you also have a PhD, and you've done some research around AI. Can you tell us about your work and educational background and your relationship with artificial intelligence?
Sure, my pleasure. I was raised on a pig farm in rural Canada, and the first job that I was paid to do work was actually AI research for the Canadian government. Actually, initially as a summer job while I was studying undergraduate in electrical engineering and computer science. From that, I did two companies and a PhD all around AI for designing computer chips. Things like machine creativity for creative design of analog circuits, as well as variation-aware design. So making sure that circuits yield even though sort of variations are going crazy. And those companies, both did well, and the technology is widely used, including, this iPhone that's I'm speaking on right now. Apple was a user and is a user and a customer of that technology. So, I've been doing that. Started my studies in the early '90s and started getting paid to do AI hacking in the mid '90s, late '90s, and that continued straight through until a few years ago now, where I went kind of full time into blockchain, and it was just blockchain for a while, but I kind of missed the AI, and that's one of the things that led us down the path to be doing Ocean, where it's combining both AI and blockchain. AI is kind of my first love, but also blockchain, realizing that if we use it in the right way, then it can give data scientists and AI researchers kind of new powers. So.
Great, and we'll jump into Ocean Protocol in just a bit. So, being involved in AI for over 20 years, what are some compelling, use cases or technologies that you have seen with AI over that time frame?
Yeah, so it's kind of funny in the '90s. It was pretty rare to see actual industrial use cases. So me and friends would gather little lists of interesting use cases here and there. In the cases for us, it was like, okay, when Sony shipped their PS3, they had massive yield problems, and that's why there was a 9-month delay. They couldn't get their chips to yield. They become one of our first customers, and using the technologies that we provided, then they could actually design their future chips to hit the yields they needed. So when PS4 came out, it was good. So it sounds a bit mundane, but at the heart of it, it's actually AI to help drive Moore's law. So, right, as transistors get smaller and smaller and smaller, atoms don't. So you have crazy variation, and it's actually gone beyond the realm of humans being able to understand that. So how do we keep, halving the size of the area of transistors every 18 months? And the answer is actually AI is taking care of the delta. So to me, given the deep importance of Moore's law to humanity, that's a very cool application that's not well known, but I'm very proud of for helping have a hand on that. In the last 5 years, AI has gotten super popular, and it's a lot around classification and regression. A lot of challenges in vision were now solvable in ways that weren't solvable before, because basically Moore's law hit AI. We have way more data than we had before. We have way more compute, and we can apply the compute to train these super large neural networks called deep networks in order to solve problems that people have been trying since the '50s, but now we can finally solve them. So things like automatic labeling of images, such that when you go to do like an image search, it can find those images very, very quickly. And towards things like autonomous driving, which will actually have a lot of benefits for humanity.
And it's amazing to see that we're seeing those integrations today being placed. And with AI comes data, and Ocean Protocols sort of working to connect AI and data, both data scientists and people that have access to data needed for AI. Can you discuss a little bit about the relationship between data and artificial intelligence?
Sure. So AI itself, it has a lot of definitions, and just like in blockchain land, no one fully agrees on the definitions. So to me, it's nice to have sort of a list of 5 or 10 different definitions of blockchain and 5 or 10 definitions of AI. Um, One of the definitions of AI is simply an umbrella of different technologies that are still sufficiently mysteries that they can't really haven't been really converted into sort of a repeatable discipline that you can just engineer a solution. And so with that, some of those umbrellas of technologies are things like genetic programming, where it's automatically evolving computer programs to solve problems, a variety of them, or fuzzy logic, or swarm intelligence, artificial general intelligence, all of these. And one of the subsets of these had been neural networks, and because sort of data hit the neural network land strongly, it led us down to this path of deep learning. And neural networks before, I was playing with them in the mid 90s, and they were really, really finicky to work with, really hard. They would overfit like crazy all the time. I don't think I ever deployed a neural network in production in all my years, even though I tried, a lot here and there. It would be always in the list of technologies to try when I was solving a new classification or regression problem. But actually, interestingly, what happened to your question, what's the relationship between AI and data? In the early 2000s, some researchers at Microsoft discovered that well, actually, I'll just give another sort of precursor here. In my early work in AI and others too, a lot of people, what we would do, we would have a fixed size data set. My work for the government of Canada had 20,000 data points, and I tried a whole variety of different algorithms to try to get better classification accuracy. So I would try neural networks and support vector machines and linear models, genetic programming, all this sort of thing on that fixed size data set. And after several months' effort, I could only improve the accuracy from 55% to 65%. But that still means it's 45% error and nowhere near deployable, right? And this was kind of the standard, right? The researchers would kind of iterate on data sets that were pretty small, and most usually you couldn't get to an accuracy that was good enough for it to be deployed. But what researchers discovered in the early 2000s was, you know what? Let's just keep the same algorithm and add way more data, not just 2x more data, but 10x, 100x, 1000x. And then it turns out that your errors are going to go down from 40%, 30, 20, 10, 5%, even 1% and less, just by adding way, way, way more data. And Google actually published a paper in the mid 2000s called The Unreasonable Effectiveness of Data that sort of showed several examples of this, not just the Microsoft example, but others. And so then, the race was on, especially for Google, to find as much data as they could, and that's why they did things like Google Maps and buying satellite imaging companies, et cetera. It's all in the name of more data, so that their algorithms can be more accurate. So, not all of AI is modeling, but the AI that does have modeling, which includes all the deep learning stuff, all of that stuff really, really loves data. And given that deep learning is sort of the sort of hot new thing, because it's solving a lot of problems in computer vision and other related fields with sort of an easier UX, just because you have more data, and it has better tricks to avoid overfitting these days too. It's sort of a match made in heaven. So these networks just love data. It's sort of like this gas that expands to fill available space. So just give it more data, they know how to consume it now and improve the accuracy correspondingly. So there's, the demand side for data is insatiable, but the big challenge is the supply side. How do you get more data? And that's really, really, really the challenge.
Great. That's quite interesting there as far as AI and modeling. So it goes to statistics. It increases your confidence. The more data you have, the smaller error you're likely to have, and therefore comes this a need for more data to help reduce the error. And you mentioned the data problem, right? So we have these companies that have a massive amount of data, and then we have other these projects that are in need of that type of data. So can you elaborate a little bit on that data availability problem?
Yeah, my pleasure. So, yeah, you have a lot of enterprises where they're sitting on reams and reams of data, and they want to mine it, they want to learn from it, but they're having trouble hiring AI researchers and data scientists. Why? Because all those AI researchers and data scientists know that they're valuable, so they're off doing their own startups. And funnily enough, those startups that they do, they forget that they need data. They're like, oh, algorithms are the best. Algorithms are the best. Then they go to do what they need to do, and they realize they're missing the data. So it's been very hard for them to monetize as AI startups. Now, there's a small handful of companies that have both data and AI expertise, and that is Google and Facebook, and a small handful of others. And they figured out how to connect, to monetize on this data by using sort of AI is the refinery, if you will, to extract value from the data. And they have captured a large amount of the overall value of this sort of data economy that's out there right now, but it's sort of a shadow data economy. So that's the challenge. Google and Facebook are the exceptions, whereas you have these big Fortune 500 companies that, yeah, they're trying to figure out what to do with their data, and the startups are crying to have data. There's an additional challenge too. The Fortune 500 companies and also UN, NGOs, and so on. Um, uh, there's this challenge of data escapes. So if I have data that I consider that might be valuable, how do I extract value from it without it sort of jumping out of my from behind my firewall and someone else grabbing it and running with it and never paying me, right? So that's a big problem. Also, the fact that a lot of data, like medical data, for example, you have to be very careful with because it's got a lot of personally identifiable information, and that you can't let get out there in the wild. It's just really dangerous for the individuals involved. And countries have laws around this too. For example, Germany, medical data cannot leave German soil. So, and that's a really good thing. So, how do you, for example, conduct medical research across not just one or two or three hospitals in Germany, but across 100 hospitals throughout the world if the medical data can't leave the soil? So these are big, big, big challenges. Everyone knows more data helps, but they've been having trouble getting at it.
So here's where comes Ocean Protocol, the project that you're working on to try to connect sort of the data, the people that need data, and the data suppliers. Can you talk about Ocean Protocol and what it's all about? Is it fair to say that you're working on a shared database for the internet?
It's That's maybe one way to describe it, although it's there's probably more precise ways. So I'll describe. So overall, at the heart of it, the mission is to equalize access to data and AI services across the board for the world, right? It's a permissionless network, all this sort of thing. But while at the same time reconciling privacy needs, worries about data escapes, and all of this. And it does so in several facets. So, first of all, we want to see a lot of data marketplaces and data exchanges emerge, right? Not just one, but a whole bunch. And the example there in history is if you go to an airline, if you go to kayak.com and search for airline flights, you'll see a bunch come up. And it's pretty cool. Or if you go to expedia.com, you'll see those same flights pop up, but it'll be a different interface. If you go to other travel sites, similar thing, different interface, perhaps wildly different, but it's actually seeing the same underlying data. That's because there's one underlying core database that actually has all this list of the airline flights that all the different airlines have contributed to, and that's being made available to the various last mile marketplaces like Kayak, etc. So the underlying database is called Sabre/Amadeus. So what Ocean is, it's like Sabre Amadeus for data itself. Rather than just airline tickets, it's for data itself. And it's a substrate where lots of marketplaces can get built on top, whether it's marketplaces focusing on a particular vertical, like autonomous vehicles or particular types of medical data, etc., or something more broad. And finally, actually, it incentivizes for our data commons as well. So we believe that a lot of data out there, is meant to be part of the commons, free to use, not priced. and we want to incentivize people to contribute data to that commons. And so what Ocean does for that is it uses its block rewards to help reward people to contribute data to the commons and then to verify that others have done so. So that's the heart of Ocean. It's really incentivizing towards the supply of data, whether it's priced or it's free. And it's got a bunch of plumbing to help people connect the people who are supplying the data with the people who are using the data. Among that plumbing, it has elements related to privacy preserving compute. So for example, German medical data that can't leave German soil, that's fine. You bring the compute to the data. For example, to say you've got a database in a hospital in Munich, you could have federated learning that comes in and updates the gradient of the neural network from within that hospital. And then that gradient update gets sent to a neural network that's also being stored in a decentralized fashion. And in this way, you can access hospitals not only in Munich, but in Berlin and in Singapore and in Orange County and elsewhere. And instead of having access to just 100 or 1,000 individuals worth of data, then you have maybe 100,000 worth. So that's kind of what Ocean is about, really like going for the jugular of just way more data sets available via easy to set up marketplaces, via incentives, block rewards to supply data, and via privacy preserving mechanisms that also address the data escapes issue.
Great. I thought that was a great example or metaphor that you brought up with the airlines and the ticketing, flight information. So you're building a platform that allows for multiple data marketplaces, and with that comes security, and you want to make this accessible, easily accessible for people. You often don't hear easily accessible and secure in the same sentence, because that's very difficult to do. So what are some of the ways that you're working on increasing security, making this easily accessible? Is this where the use of blockchain comes in?
So with blockchain, Ocean is actually designed to be very, very thin. At the heart, it's what I call curated capabilities. So this curation where you stake on what data or AI services you think are important in a sort of staking mechanism in the blockchain sense. And then capabilities as in object capabilities. This is authentication. Are you who you say you are? That could be as simple as just a private key, but it could be fancier. I mean, a public key or fancier. Authorization, which is permissions to access particular assets, and then the service itself. And this is simply an endpoint. So Ocean is very, very thin. You can think of it, or even simpler, a curated permissions system. And then the services that are being provided are provided by third-party services that are either centralized or decentralized. So, and this is data or compute. So from a data perspective, it could be data that I'm providing from behind my firewall, maybe even on my phone or something, and I'm providing that through the keys. Maybe I'm providing it to you. Ocean acts as a broker to exchange the keys, but the data itself does not flow through Ocean. You and I are actually exchanging in a more peer-to-peer fashion with a sort of handshaking of the keys and the flow of value by Ocean. So there's the centralized data suppliers, and this is important. There's also the cloud type thing, so maybe serving off of Amazon S3, for example, AWS S3. And then there's decentralized data supplying too, such as via Filecoin or Ethereum Swarm or something. And there's also the Oracle networks like Chainlink. Similar for compute, it can either be centralized behind a firewall, especially for the privacy where you're bringing the compute to the data. It can be on the cloud, say Amazon EC2, or it can be decentralized compute, such as Golem in a more generalized sense, or maybe say Enigma if you want privacy preserving decentralized compute. So Ocean is designed where all these services are treated as services in Ocean, and then Ocean has mechanisms to verify that these services were indeed provided. So Ocean is sort of a network of networks that it's got a very thin connective tissue that is really all about, was the service provided, yes or no? Did the payment happen, yes or no? Are the keys handed off back and forth, yes or no? And then in terms of ease of use, that's where the third-party marketplaces come in for buying and selling. But also, if you're a data scientist, then you're going to be using Ocean via your traditional data science tools. And those are things like scikit-learn, which is the top data science tool that isn't deep learning. And we work closely with those folks. or Anaconda, which is the top Python distribution for machine learning and numerical processing in general, and then all the other sort of deep learning things too, things like TensorFlow, et cetera. So over time, we're going to be building integrations into each of those, and it's via very thin drivers like Python drivers, et cetera. So that's kind of what Ocean is about, sort of top to bottom. It, depending on who you are as a stakeholder, then you're going to have different interfaces into the end.
Great. So it's great to see that you have many different integrations, as a data set can be anywhere. It can be, an Excel sheet with thousands and thousands of lines of information, or as you said, it can be in a Amazon, AWS, EC2 database. So with this, you mentioned a block reward, and there's different ways. You said there's the ability to have free data and also marketplaces to buy and sell data. So on our agenda today, you added on the use of mining. So can you discuss a little bit about how that works with mining and block rewards?
Yeah, sure. So, I'm sure all the listeners to your podcast understand the idea of mining and say Bitcoin, right? Where if you have something with a lot of hash power, maybe some fancy ASIC farm, then you can be earning Bitcoin. And what you can expect to earn in Bitcoin is if you say contribute 10% of Bitcoin's hash power, you can expect to earn 10% times the block reward every 10 minutes, which is 12.5 Bitcoin, right? So your expected reward is 1.25 Bitcoin. And so why does Bitcoin reward that? It's because Bitcoin it has its own objective function, which is maximize the security of the Bitcoin network. It defines the security as the hash rate because that's the difficulty of unrolling its transaction log, right? And so that's sort of Bitcoin. It's basically solving this objective function. Ethereum has the security plus extra incentive to run the scripts that people supply to it in Solidity, et cetera. So in Ocean's case, Ocean's objective function is maximize the supply of relevant data and services, right? And so we want to make sure that the block reward corresponds to that, where people are rewarded if they supply said data and services, and it has to be relevant. And so the relevant part we address by staking. If you think something is going to be valuable, going to be used a lot, et cetera, then the more valuable, useful you think it is, the more you stake on it. But of course, if no one tries using it, then you're not going to get any block reward. So you get rewarded as a function of how much you staked and whether or not it gets served up. And the more that it gets served up, the more that you make as well. And this is for data, for the commons data, and then also for priced data and services. Then you get rewarded as well. And that also comes in the form of, actually making money, right? With price data, the more that I sell, the more money I make, just even without the block reward. So I'm actually pretty naturally incentivized to serve that up.
So what these marketplaces, and you mentioned some transactions are peer-to-peer. Is it all done through tokens? So as far as buying and selling data and getting that reward, is it all in the form of a token? And can people use different um, paying mechanisms to purchase data?
So in the Ocean system itself and the network, everything operates with the Ocean token. So Ocean is used as a staking token for staking on data and other assets, and it's also used as a medium of exchange for buying and selling services. But at the marketplace level, one level above, those marketplaces themselves can have payments in whatever unit of exchange they want. It could be US dollars, where they automatically convert to Ocean tokens. It can be Ether. It can be whatever they want. But within the Ocean system, it's all in Ocean tokens. And this was a very explicit choice. We wanted to make sure that the Ocean token combined a unit of exchange with store of value in the staking sense. Because we've seen in the past, Joel Monegro talked a lot about this. We've seen in the past where if you separate the asset owners from the people that are spending cash for sort of getting by day to day, then it leads to inequalities, et cetera. And in the case of crypto systems, that would be if you do separate them, you have a two token system, and it actually increases a lot of complexity. So our whole thing is we just say, you know what, do a just in time exchange if you don't want to hold Ocean tokens. But we do see that over time, Ocean can be viewed as the token used for purchasing AI services, AI data, and other AI assets, right? And it kind of makes a lot of sense. Out there in the world of the sort of the crypto token economy, Bitcoin has become the store of value, and Ether is the main unit of exchange for these different services. But that all of that stuff is really targeted towards a web app stack, that sort of compute stack. But the AI stack is actually a different stack, right? So instead of JavaScript and Heroku and all these sorts of things in the web app stack, you have things like I was talking about already, Anaconda and Python with scikit-learn and TensorFlow, and then the big data backends, things like Flink, Apache Spark, this sort of stuff, right? So it's actually very different stacks, and we see that Ocean can end up being the de facto standard towards those AI compute stacks.
So going back to use cases for a decentralized database, earlier you gave a couple examples, and in your publishments, I've heard you say that Ocean provides superpowers to data scientists. Can you provide like one or two examples of use cases for data and how this ultimately leads to enhanced AI?
Yeah, sure. So that's actually probably three separate questions. So maybe we'll just do those one at a time. On the superpowers part, I break it down into three parts. The first one is way more data, right? And I was talking with a friend last week who spent many, many years building genetic programming models to predict cancer. And he said, Trent, you're the happiest person in the world if you've got a data set of 100 people, right? And I'm like, so he was telling me about that. And also, that's just from one hospital, right? And there's actually bias from site to site. So, one hospital, they might take out cancer cells and then measure them right away. In another hospital, they might leave them in a petri dish for 10 minutes and then measure them. But by that time, half those cells have died. So, a study that works in one hospital might not work in another. So, but imagine if you can actually get a data from across several hospitals readily while addressing privacy issues, right? So, and that's actually, so the way more data thing can be super, super useful, resolving site-wide bias and other issues. Another example in the way more data part is self-driving cars. So Rand did a study and they saw that to get to the accuracy that we need for self-driving cars, we need 500 billion miles driven. This is not simulated miles. This is actual driven miles. Toyota Research Institute came to us and said, hey, we've looked at the numbers and we realized that it's going to take us more than a decade, maybe 15, 20 years to get to the point where we'll have enough data in order to have autonomous vehicles. What we realized is let's pool our data with others. Let's work with the GMs and Fords of the world. So we actually built a prototype with Toyota Research Institute, and that'll work nicely. That was more than a year ago now, and from that we said, well, actually, Toyota, the person running this, Chris Bellinger out of Toyota, he realized that to make this an industry-wide thing, he'd need to create a consortium independent of Toyota. So he left Toyota and created something called MOBI, which is an alliance that has more than 70% of the world's auto production now, including GM and Ford and BMW and others, and a total of 100 big enterprises, all the big insurance guys too. And one of the main projects there is a decentralized data exchange, and we're basically working with them very, very closely to make that a reality. And this, obviously, with self-driving cars, it can make a big difference for humanity in terms of enhanced mobility, way fewer accidents. There's this kind of long-term dream of imagine that the accident rate literally goes to zero. Not in the next 2 years or 5 years, but imagine 20, 30, 40 years from now. So that's sort of superpower one, way more data. The second superpower is provenance on AI data and compute. So, for example, here in Europe, the GDPR laws talk about you need to actually explain how you arrived at a model, how you arrived at anything that you're using. But these deep networks, they're complete black boxes. But what if we actually had full provenance of all the data that was leading to that, full provenance of the training that happened, et cetera, as well as really nice tools for data mining the neural network itself, which I actually worked on over 10 years ago myself. So that's very useful. Or and a nice example, once again, in the autonomous vehicles, in airplanes, there's black boxes that sort of talk about what went on in the flight in case the airplane ever crashes. We could actually have similar black boxes for cars that can show us the whole history of the car. Also, management of big data within the enterprise is really, really a problem. Provenance is a major, major issue, and Ocean can be used even within a single enterprise, within sort of an enterprise-wide tribe, where they have permissioning just for that enterprise, and that's going to be very valuable there. They get the security levels of a public network, yet they get the privacy within their own local network. The third superpower, which is also not to be forgotten, is you can make a lot of money as a miner. So in the case of Ocean, you can be mining by serving up data or compute or curating. If you curate on other people's things, assets, and help to serve those up too, you can make money. And these assets, the data, it can be raw data. You can also clean it up. Add labels to unlabeled data. You can clean up data in other ways. Remove outliers. You can create new algorithms and have those within Ocean as a service. All of those things are ways to make money that were a lot harder to do before. So those are kind of the superpowers that I see. Once again, way more data, provenance on AI data and compute, and finally, making money.
So with data, and it involves getting a lot of data. So with Ocean Protocol, you mentioned like the examples of the hospitals and getting data from all those different hospitals. So what does it take to so a data marketplace? You need listings and you need a lot of data to be placed on there. So what does it take for somebody to, or what will it take for somebody to place their data either for availability or for sale on a data marketplace, and how do you plan to get sort of these massive amounts of data?
Yeah, so we're approaching it from the perspective of the problems that people are trying to solve. So in the case of the autonomous vehicles, the suppliers of the data are also the users, the big automakers, right? In the case of medical, one key use case we're working on is for prediction of Parkinson's via a partner company in Munich called Connected Life. And they've been working with hospitals and the university, et cetera, for years and years. So they have a very strong understanding of their needs, but they need Ocean in order to help address the privacy issues, et cetera. And just keep doing this one problem at a time, et cetera, et cetera. Another big set of problems that we're working towards is an initiative called the AI Commons. And this is an initiative spearheaded by Amir Banafatemi, who runs the AI X Prize. And Amir and Stuart Russell and some other famous AI researchers have been working on this, and we've been iterating a lot with them too. And the idea of the AI Commons is to connect people with problems to solve that can be solved by AI. So to connect those problem owners with the data scientists to help solve the problems. And the problem owners tend to be, in their case, they're going after and iterating with the UN agencies. So, say the agency around agriculture that's trying to help get better predictions of how much fertilizer you should put in your crop in rural Africa, right? And so that's sort of a problem owner. And then connecting that data to researchers at, say, Yoshio Bengio's group at the University of Montreal, and helping to make those models. So Amir had been doing this along with Yoshio and others in sort of a manual way, but Ocean actually is set up nicely to do this in a much more low friction way to scale the challenges. So with this sort of AI Commons as part of an overall AI for Good movement, there's about 40 UN agencies they're iterating on this, as well as Amir with the AIX Prize, Ocean, and others. So that's basically a big source of interesting problems to address. Within Ocean itself too, we're iterating with the government of Singapore and especially their data authorities called IMDA, and they actually have a whole set of customers that want to use Ocean in various ways too, that are coming with their problems. And then Ocean is helping to tee them up to help address those problems via this connective tissue of the problem owners with the problem solvers.
Great. And in your post, it's definitely a great way to start gathering data is by getting relevant data to problems, real problems that people are trying to solve. And so with that example of the Parkinson's research, is that an example of what you mean by creating data marketplaces to create society level impact?
Well, so to me, overall, I see the society level impact coming sort of one problem at a time. At first, it will be a small handful of problems, 3 problems, 5 problems, 10 problems, 20, but that will keep growing and growing to 100 and 1,000 and so on. And removing the friction to be solving those problems, connecting the people with the data and the problems to the people that can help to solve those problems. That's where we get the society level impact, right? The web impacted the world, one web page at a time, right? But of course, it grew exponentially, and overall had a very positive effect on the world. And we see a similar thing with Ocean, but we have to do it where it's addressing real problems from day one. The web was initially invented so that Tim Berners-Lee could share data, actually, interestingly, with his buddies at CERN, the particle accelerator facility. So, and it turned out, like the web is only so suited for that, but it's really great for documenting pages, right? Like one massive hypertext page, right? That's really what the web is. So yeah, Ocean, that way, that's how we see the society level impact will happen in the near term, is helping to unlock the potential of data and AI for all these, especially AI for good initiatives, right? In the longer term, we see sort of, other bigger ramifications too, but that's really what Ocean will help to catalyze. And that's the marketplaces will be a piece of that. The data science tools, there's a whole bunch of different pieces that basically work together. But at the end of the day, it's about helping the people with boots on the ground, right? The farmers in rural Africa, or the farm boys in Canada, like I was many years ago, and so on.
Great. So these improvements overall makes enhance society for the better. So there's other projects out there that are working on AI as well and data economies. Can you sort of compare what or describe what a data economy is and how it compares to a data marketplace and what Ocean is building?
Yeah, so there's a few projects that are doing decentralized data marketplaces, and to that we say, awesome, right? Please plug into us, and then you will be able to have a greater access of other data to be selling on your marketplace, and the data that you've already plugged in can be made available to others. So greater liquidity for all is a win-win, right? There's people that are working on AI compute. Um, People like SingularityNet, for example. Great, the SingularityNet network can plug into Ocean, and that will provide particular brands of training models, which is wonderful. So each of those initiatives is creating a decentralized network that we view as a service network that plugs into Ocean. And Ocean is unique in that it incentivizes these various service networks to provide to hook into Ocean, because the users of the service networks will be getting Ocean tokens in addition to whatever else they do in their network. They'll be getting Ocean tokens if they're hooked in. And so Ocean is sort of configured in a way where it's very easy for us to collaborate with other projects. And so we have been, right? We have longstanding talks with many projects, and we're starting to integrate them now that the software is at sufficient maturity. I should mention that too. Overall, Ocean has 3 releases and then the mainnet launch. So 3 releases in its roadmap. We're done the first release. We're partway through the second, nicely on track. The first release was on scope, on time. And it's out there, open source. People can download it, play with it. We have documentation, all that. People have been even writing about it, writing blog posts, etc. And then mainnet launch is targeted for March of next year, and we're on track for that too.
Great. And I want to end the show with a forward-looking question and ask you, where do you see the future for AI and blockchain? You have sort of an add-on to this question. You have this long-term goal to ensure that there's a place for humanity in this increasingly autonomous world. Can you tell us a little bit about where that came from and where you see the future of AI and blockchain?
Yeah, sure. My pleasure. So, um, as an engineer, I find it easier to interpolate than to extrapolate, and this includes sort of modeling your career as well as what you do in your career, year to year. And so, rather than sort of having this sort of cascade of information just flooding you all the time, what do I do next? What do I do next? I like to try to paint models of what the future might look like in 20 years, 50 years, 100 years, um, and actually the type of future that I want. And getting inspired by various sci-fi writings, etc. So thinking about the future that I want, and then connecting the dots, interpolating. So in doing that, how I see things 100 years from now, there's a very good chance like that everything is patterns of intelligence living on some silicon or post-silicon substrate. The AIs are going to be there, the derivatives of AIs, and I really, really hope that the derivatives of human brains and minds will be there too. And I see that how we can get from here to there is by thinking about it a lot and how do we connect the dots. So rather than sort of being left behind, and sort of a near-term being left behind is actually with respect to jobs, right? In America, there are 3.5 million truck driver jobs. There are already production self-driving trucks on the road. They're only on very simple roads right now. They can't handle blizzards and all that. But in the next 5 years, 10 years, as autonomous trucks start lining up, that could decimate all of that. And not only the truck driver jobs, but also a lot of middle America, which has the hotels and motels for the truck drivers, the gas stations, all of that, that could get wiped out. Or the 6.5 million retail jobs that are under severe threat because of things like Amazon Go, the store that doesn't have any cashiers at all, and not to mention the taxis, etc. So I see that in the near term. These are real challenges, and they're going to kind of come, because of market incentives. But I see that Ocean can actually help to provide a transition if we can set things up where there's a social safety net for the citizens. As these automated machines get set up, their surplus can be directed towards the social safety net that helps these people that have lost their jobs and so on. So things like UBI and so on. So that's kind of how I see things. In the near term, it's really about like helping data scientists solve these better models. But then as time goes on, it's more about helping to provide this really hopefully benevolent substrate to help humanity upgrade, if you will.
Great. And so you obviously have a very extensive background in AI, over 20 years of experience. So where can listeners learn more either about you and about Ocean Protocol?
Sure. So to learn about Ocean Protocol, the best starting point is oceanprotocol.com. And then on Twitter, it's at Ocean Protocol. Off of oceanprotocol.com, it has links to the blog, to various other events that are coming up. We're often at events out of Europe. A lot of the team is based out of Berlin, or out of Asia. A lot of the team is based out of Singapore as well. So that's Ocean Protocol. And for myself, you can follow me on Twitter at TrentMC0, or my personal site is trent.st. But I encourage, everyone to check out Ocean, and you can go to GitHub and download it and start playing with it. It's still pretty early, but at the same time, we're making great progress. And with every passing day, I'm getting more and more excited about how this is going to end up being an indispensable tool for data scientists, which in turn will help to drive, all these awesome use cases to help the world.
Great. And for the listeners that are watching live right now, just going to give a quick shout out to those of you in the chat. Brittany, Kidsoken, Pete, Tony, Mohammed. Thank you all for watching live. I'll go ahead and add those links down to the description below. As far as OST Live, we have announced our upcoming guest next week. Later on today, we're going to be posting a recap of this with a summary of our discussion and links to Ocean Protocol. Next week, on October 24th, we have Pavel Baines. On October 31st, which is Halloween, we have Ben Chan. And on November 1st, the following Thursday, after Halloween, we have Nate McConaghy. You can learn more about these individuals in our Medium post. And thank you all for watching live. Trent, thank you for joining us on OST Live today.
Thank you. It's been a pleasure.